Let's talk about IOC, inversion of control, and dependency injection, starting with an example. Imagine a class that uses different services. For example, when we'll implement logging in the upcoming demo, our points of interest controller will use a logger service. That's a concrete type, specified at design time. This means that the points of interest controller has a dependency on the logger. We'd typically new it up in the constructor. And let's say it also depends on one or more other services. Problems arise when you need to replace or update that logger. The controller's source code will have to change. It also makes the controller harder to test. You can't just replace the logger with a mock version of the logger, as we're using the concrete type. And lastly, the class needs to manage the dependency's lifetime. In short, this is tight coupling. And that's where the IOC pattern comes to the rescue. It delegates the function of selecting a concrete implementation type for the controller's dependencies, which is the logger, to an external component. But how do we do that? Well, that is where the dependency injection pattern helps. This is a specialization of the inversion of control pattern. The dependency injection pattern uses an object, the container, to initialize objects and provide the required dependencies to the object. We've talked about that container before. You register services with the container, and the container is responsible for providing an instance of it to the class that needs that instance. It thus manages the lifetime of the dependency. And we've effectively done this when we learned how we could get a file. At that time, I mentioned that a lot more information on the subject would be coming up, and this is when. Let's have a look at a code sample. We've got a backing field to hold the dependency, but that's not a concrete implementation. We're expecting a class that implements the iLogger interface, in this example, typed to the controller. So we're working on an interface and not on a concrete implementation. That's one of the basic principles behind OO design. The constructor has changed as well. This is constructor injection. The constructor of our controller needs an instance of a type that implements iLogger. Again, no longer the concrete type, it's an interface. The container injects the dependency for our class. The net result of this is that our class, the points of interest controller, is decoupled from that responsibility and from the concrete type. The dependencies can be replaced or updated with very few or no changes at all to the code in your class. And the class itself can easily be tested because those dependencies can be mocked by providing a mocked version of the logger. Some services are built in and by default registered with the container, like a logger. Others can be added by registering them on the service collection in the program class. Both framework services and our own application services can be added. In fact, we already did that previously, both when learning how to work with file and when we registered the required services for working with controllers by calling into add controllers on the services collection. As usual, Microsoft's documentation regarding this subject is thorough. You can find it via the links on screen if you're interested in this. But all you need to know for this course will be explained during the demos. And let's immediately continue with one of those. We're going to learn how to inject one of the built-in services, a logger, into a controller